Okay, so in this video we're going to take a look at how you would use Q and compare that to K to find out where you are relative to equilibrium, and whether you're going to make more products or make more reactants to reach equilibrium. And then the next video we'll set it up and actually solve for how many, what the final concentrations are of the products and the reactants would be. So you can read through the setup right here, but essentially we're given initial concentrations of the three gases that we're looking at, and we need to know in what direction we need to proceed to get to equilibrium. So first thing I'm going to do is write the K expression, which is simply concentration of SO3 squared over concentration of SO2 squared times the concentration of O2. Alright, so that's going to be equal to Kc when we're at equilibrium, but in this case we don't know that we are. So you write this Qc, the reaction quotient, basically think of this as a stand-in for K until we find out where we actually are. So all we're going to do is insert these values into here. So for the SO3 we'll do 4.0 times 10 to the negative second molar squared. We're going to divide that by SO2, which is going to be 4.0 times 10 to the negative third squared times, and the O2 3.5 times 10 to the negative third. Okay, I go through and I solve that, and what I'm going to get is my QC is equal to 2.9 times 10 to the fourth. Okay, if I compare that to my Kc that I'm given up here is 7.9 times 10 to the fourth. So we have a scenario where this Q is less than Kc, right, which is equal to 7.9 times 10 to the fourth. So that means we're going to need to make more products, because as it stands right now, our denominator is too large relative to our numerator and we're coming out a little bit low. So we're going to have to add to the product over here, make that 4.0 times 10 to the negative second will have to be more. It'll come at the expense of subtracting away from the two reactants from the SO2 and the O2. So you'll proceed from left to right and you'll make more products in order to get to equilibrium.